Hey all you cool sabers! Today we are going to talk about connecting variation, slope, and first differences. So, let's see. A mathematical relation can be described in four ways. We can describe it using words, a graph with numbers such as a table of values, or an equation. Obviously, the best one is the equation, which is a mathematical statement that states that two expressions are equal. For example, y is equal to 2x plus 3. An equation of a line is in the form y equals mx plus b. All right, so I briefly touched on that when we talked about partial variation, that this is what it will look like. Specifically, the m will be the slope of the line. So the m will be a number, and that will tell us what the slope of our line is. The b is the y-intercept. Okay, so that's where the line will cross the y-axis. Now, if we think about this, and I'm kind of jumping ahead here, but if the y-intercept is equal to 0, then b is equal to 0, in which case you wouldn't write plus 0, which is why that is our direct variation that we talked about. So remember, if that plus b is not there, it's direct variation. All right? The x and the y are the points on the line, so those will always be a y and an x. When you write your equation, the x and the y will look like an x and a y. It won't be a number. Okay, if you're using the equation, you could put numbers in potentially, but not while it's in the equation. All right, so this is, the x is going to be our independent variable. Independent. Okay, oh, I think that's an E. Independent. Yes. All right, so our x is our independent variable. In other words, we pick our x and it tells us what y is, because y is dependent on what x is. So y is our dependent. All right. Let's see. So for our first example, we've got a slope of 2 over 5 and a y-intercept of -4. Okay, so if we were to put that into an equation, all right, then we would say y, hold on, let's see, let me zoom in here. So we got y equals m x plus, well, let's use green, b, okay? Our m is equal to our slope, okay? Oh, I just underlined that in the wrong color. Let's try that again. There we go. M is equal to our slope. Our b is our y-intercept. So we just take those two numbers and we just sub them directly into that equation. So we will have y is equal to 2/5 x plus, what was it, -4? Oh, it was -4. So actually it's going to be, so it would be plus -4, but we don't write it that way. We're just going to write -4 like that. Okay? So that is the equation of our line. All right? Okay, so let's identify the slope and y-intercept of our equation. We already did that. I just did that. Oh, so sorry. No, I can't read. I don't know how to read. We're using these ones over here. So all you have to do to find that slope then is to look in front of the x. So we're going to find it by reading the number in front of the x. So read, I don't know how to spell either apparently, the number in front of the, I'm going to write just in front of the letter, okay, because it's not always an x, but usually it's an x. Usually x, okay? So for instance, we will do ones, we've done ones where, you know, we determine the cost of something based on the number of something else, so cost based on number of people, and so we had a c and an n, so it would be the number in front of the n in that case, but often it is an x. Certainly if we have an x and a y, it is the x. There shouldn't be a number in front of the y. To figure out the y-intercept, we want the number by itself. So we read the number by itself. Okay, so for instance, up here, this was our slope because it's in front of the x. This is our y-intercept because it's by itself. It doesn't have a variable attached to it. Okay? All right. So let's take a gander. On this chart here, we've got 3x. So the number in front of the x is the 3. And we have plus 5. So the y-intercept is 5. All right? Again, it's not necessarily an x. It's often x, but not necessarily. In this case, we've got an n. So the number in front of the n is -4. The number by itself is -8. Okay, and it is important to notice that if it's a minus, that goes with the y-intercept. It's going to be a negative number. All right, now this next one is intentionally to mess you up. You'll notice that the term with the x is at the end. It doesn't make a difference. It's the number connected to the variable. So it's going to be our -2 or our -2. Okay, and the number by itself is our 11. Okay. In this case, we've got ourselves a direct variation question here. Our slope is still the number in front of the x. It doesn't matter that it's a fraction. It just means our slope is a fraction. But then there is no number by itself, and that just means that our y-intercept is equal to 0. All right? If you are missing a number by itself, your y-intercept is 0. Direct variation. Okay? All right, so what if we are given the graph, though? So this is where we're going to follow some steps here. I didn't really give myself enough room here, so I'm going to zoom right in. Okay, so if we're given a graph, what you're going to do is you're going to do 3 steps. The first thing you're going to do is pick 2 points on the line. Whoops. Pick 2 points on the line. All right. The second thing you're going to do is you are going to find the rise and the run. Rise and run. It's a weird looking R I did just there. All right. And then finally, your slope is going to be equal to rise over run. And usually you want to give it as a fraction. You want to reduce the fraction, but usually you want to give it as a fraction because it's a lot easier to work with. It's going to be a lot easier to graph, to use as an equation. It is. The only time you're going to use decimals really is when we're doing application questions where it doesn't necessarily make sense to use a fraction. Okay. So then to find the y-intercepts, okay, this is actually fairly easy. Finding the y-intercept is a lot easier than finding the slope. You only have to do one thing. You just have to read the graph. You're looking for where the line crosses the y-axis. So read where the line crosses the y-axis. And that's it. You just have to look there, okay? And that just tells you the information. So we're going to look at this example here first. And I'm actually going to do the y-intercept first. I always do the y-intercept first because it's a lot easier. So let's just get it out of the way. We just look at this line and we say, well, we crossed the y-axis right there, okay? So that's going to be a 1. So our b is going to equal 1. So let's just jump over to our chart here. And we have a 1. Now we're going to do our slope, a little bit more difficult. You pick 2 points. It doesn't matter which 2 points. You want to pick exact points though. Okay, as long as the point is on the line, it will work. You want to pick exact points to make your life way easier. But I'm going to start with this one and this one. Okay. If I had used, say, this point here or this point here as one of the points, it wouldn't make a difference. You might have to reduce your fraction is the only thing. So I'm picking these 2 points, and I'm going to make my right angled triangle, and I'm going to say, well, my run here from this point to this point, that's a distance of 1, and from this point to this point, the distance is 2. So my slope is going to be equal to 2 over 1, which is of course the same as 2. So I can write that in my chart over here, that my slope is just equal to 2. All right? And from there, we can fairly easily come up with the equation. You just have to remember that that the equation of the line is y equals mx plus b. So we say, what does my m equal? Well, it's over there, so we got, well, hold on, let me use black. Y equals 2x, and then we need our y-intercept, which is right there. So we have plus, and it was a 1. And that's it. So our equation is y equals 2x plus 1. All right? And we'll do the same thing here. So, let's see. So let's start with our y-intercept. Whoops. Y-intercept. So it's going right through there. So that's just going to be 0. You can see this is example. Again, this is direct variation. Everything else is partial variation. It goes through 0, 0. So it's direct variation. Gives us a b equal to 0. Okay. Our slope. So we're going to pick 2 lines. And again, it doesn't matter which 2 points you pick. I'll just pick randomly. I'll pick that point and that point. All right. Again, as long as they're perfect points and they go right through the grid, so I could just as easily have used this one. I could use that origin. I could use that one, that one, that one. It doesn't matter. The one thing is, if you get the points as close together, you won't have to reduce the fraction. I wanted to do one here where I do have to reduce it, just so you can see that it does work out to the same. But if I'd picked this point here and this point here, because those are the closest together that are exact points, I wouldn't have to reduce the fraction. So we are going to have to reduce a fraction, but that's okay. So first let's do our rise. So we go from this point to this point, and we see that's a distance of 2. Now, remember, we read left to right, so this is actually going down. So that's going to give us a negative slope. And then our run, we're going from here to here. It's going to be a run of 2. So our slope is going to be negative 2 over 2, which does reduce to negative 1. All right? So we have a slope of negative 1. So we go to put this into our equation, and we're going to have y is equal to negative 1. Oh, hold on. Let's keep my color scheme up here. Negative 1 x plus 0. Okay, so your answer would be y equals negative x, or negative 1x plus 0. Now that's kind of a silly way to write it though. What we would normally do is we would write y equals, whoops, let me zoom in here, equals, and we wouldn't normally say negative 1x, we would just say negative x, and we wouldn't normally say plus 0, we would just leave it like that. So that's the same as having y equals negative x, and that's it. That's our final answer. Okay? Now, unfortunately, the next 2 aren't showing up on my version of the note. I'll make sure that your version of the note does include them. I'm not sure why that's not there. But regardless, they're not there. So I'm going to give you the answers so you can just try it out on your sheet if you want. The answers to those ones were y equals 1/3 x. So there's an example of one where the answer was a fraction. We just left it as a fraction. The rise was 1, the run is 3. And then the other one, same is true. It's actually going down though. It goes down 4 and over 3. So we have negative 4/3 x plus 3. So hopefully those 2 charts do show up on your version of the handout, and you can double check those with your version. Yeah. And that's it. All right. So until next time, go Sabres.